So when I ask about 5G, what is 5G, how do you answer? It's the F word, right? Fast. And it's low, and it's massive connections. Yeah, close enough, yeah? I'd like to put a different spin on it, yes? It has nothing to do with that. It's all about money. It's all about transformation. But today I'm going to take it a different way. I'm going to talk about why you should trust 5G. And the first one is, let's start with since 2000, what have you heard about electromagnetic radiation? Fortunately, we have skin in between and we have our skull. I'll say fortunate. Why? Because I'm going to do a Mythbusters today, right? So, number one. Up here, you're absolutely right. It fries more than your brain, right? I think we're all familiar with this here, Chernobyl and everywhere else, yes? And X-rays, I think you understand more or less how they work. We're right down here. Yep, just to put it in perspective. That's a couple of orders of magnitude below. So here's the myth. The myth is that in 2000, a gentleman did a study that the human brain would absorb radio waves, and certainly it does. Certainly, well, the tests he did were on rats and mice. But it was done on cells in a lab, not real. That's been the industry benchmark for almost 20 years. So how do we bust a myth? By telling the truth. And the truth seems to come from the World Health Organization. So this is their opinion. I don't have the date and I haven't got the report myself right now, but I encourage you to get a copy of it, and I think this is probably the first reason why you should feel good about 5G. So two key components are that your FM radio and TV actually emit more. Yeah, they emit more radiation. Yeah. And the second one is, for all of you who've been holding a cell phone to your ear for the last 20 or 30 years, I think you're probably still normal, right? I like to think I'm more or less normal. Yeah. One good reason, I think, yeah? Second good reason. You've all heard about security. Just now we had a few interviews. What's all this we hear about security and Huawei and 5G, right? 5G, security. Yes, 5G is more secure than 4G. I'll give you a little bit of an explanation as to why it is. But first of all, every time you turn on your 4G handset and you signal to a base station, your data, your ID is not encrypted very well, and it's easy to spoof a base station. How easy? A researcher in university can do it. People want to steal your credit card details can do it. It's not terribly difficult. If you've got $70 billion, you could spin some satellites around the world and do it. Yeah? So what we do in 5G is we encrypt it. In fact, I'll bring them all up and you can have a look at them all. But a couple of them are terribly important. This one here. All right. Ooh. And this one over here. Shouldn't do that, should I? And this one over here. So we encrypt it using 256 bits instead of 128. And the second one is we put it in a tunnel. You know, your SSL, the secure socket layer, thing like that. We make a tunnel. You can't see inside a tunnel and you can't see inside this tunnel. So they're two of the key things that we've done. But as you cross between different types of mobile networks, this roaming, they had another vulnerability. So we fixed that. And we fixed some authentication problems. So by design, 5G is more secure than 4G. By design. So when also you hear, we're going to go from hundreds of thousands of people, millions of people, to billions of connected things, yeah, that means we've got a bigger threat landscape, right? Sure. But if it's all based on 5G and we encrypt it and we tunnel it, don't we extend the security right down to the IoT device or to the handset? Yeah? So where is the problem in security? It's the ecosystem problem. Yeah? How many apps are there? Circa 2.7 million. And what do you do when you download your app? And it says what to you? It says quite clearly, the app is free. Can I steal your data? Sure, take it, right? That's what you say. You say yes, right? You download the app. Yeah? So the problem we have is a misunderstanding about security. The problem we have is it's a shared responsibility. Yeah? This is what the problem is with security today and technologies. All of this stuff that sits at the top there, are they secure? We use Wi-Fi here, right? You all use Wi-Fi because it's, now their F word, free. Yeah? What do you get when it's free? Any quality of service? The signal drops out, drops in, drops out. Oh, I can't get to log on. It's okay, right? But not if it's a mobile network. You wouldn't stand for it. But that's exactly what we do in mobile networks. Because this group of operators in the middle sitting here, yeah, the standards organisations and the governments, we work together to create a framework of standards to protect those things. But as we go further up this way here, with many more things connected, we need better protocols, better standards, better discussion, better collaboration. So we say it's a shared responsibility up here. And just because you pull out one vendor's product here, or you scrutinise another vendor's product here, if you don't do it this way, across the entire supply chain, you will not fix security. But 5G by itself fixes a whole bunch of security problems. So we cover it in the air interface that I just mentioned between the device and the base station. We cover it in that core network because of this thing called slicing. And we cover it in operational procedures and deployment. But this is another reason why we need people like you to explain these things to the industry. So, we've all been talking about fast, we've all been talking about industrial development. What are the real use cases? So the first one, let's have a look by industry sector, what the contribution to the GDP might be, its contribution to GDP. What would 5G do in a number of different segments? Now, we didn't commission a study to go and take data from everywhere. What we did was very specific. I told these guys who did this, STL partners, I want you to go and find out exactly where the money is, right? Where's the money? So let's take one example. Manufacturing. We picked manufacturing. Why? Because it sits up here, 4-point-something%. So we did 3. We did this one, and this one, these 3. I asked them to do manufacturing because we believe that we can transform the manufacturing sector. Yes? Why do we hear that? Because when they go and interview developed and undeveloped or developed and developing countries who have manufacturing facilities, they ask the CEO, do you understand 5G? No. Okay, we don't need to talk to you. Do you understand 5G? Yes. What do you expect 5G will do to your business? Why do you believe it will help your business? If they put more sensors in the robots, really simple stuff, going from 2 to 5 or 5 to 10, just simple numbers like that, and can connect it reliably, not using Wi-Fi, not using Bluetooth, and securely, they save a couple of % in manufacturing. And that adds up to a ridiculously big number. These are all billions. Yeah? Just doing one thing, preventive maintenance. Nothing else. Just doing preventive maintenance. So I didn't ask a consulting company to go on the internet and research and how many machines or how many of this and what do they think. Let's go and interview manufacturers and ask them about their business. Yeah? Efficiency, dollars. The second industry, I'll move over here, improves life, quality of life. There's lots of money in this. Why did we pick health? Because it's a $1.6 trillion industry. Maybe the contribution here of 1% improvement to that is a small percentage, but the number is huge. The reason it's a challenge is because if you go to the health institutions, whether you go to a doctor or a clinic or to the hospital, and you ask them, do you understand 5G and what do you think it'll do for you? The answer is very different to interviewing CEOs from manufacturing sector. They understand it less, okay? But 3 very key areas where you save lives and get money. Remote patient monitoring, virtual consultation. Let's take these 2. I think you're all familiar with a product, I think Babylon is here in the UK with NHS. So you can have an app and, I'm not feeling good doctor app. So you punch in, I'm not feeling good, left side, right side, 1 week, whatever. And the AI behind tells you a whole bunch of things and recommends what you should do and what you should take. Or it suggests that maybe you need a virtual consultation. So now you press the button, you schedule a video call with a physician. We can do all that in 4G, right? In fact, we're doing it right now in 4G. But you know the problem? There you are uploading, right? And here you are, desperate to see. Well, little Johnny's got a pain, and you want to have a VC with the doctor, right? But your neighbour there is consuming all the bandwidth in this limited area. Yeah? So here we have a critical application competing for resources with a non-critical application. And in 5G, because of things like network slicing, this won't happen. So that means things like security industry, cameras, high-speed things like cars, low latency things like robotic surgery or remote surgery or remote diagnostics will not be interfered with and not being competed for resources by other industry sectors. I'll give you the example of connected ambulance. Maybe I touched on this before, I can't remember, I've done so many interviews this morning. Connected ambulance, it saves lives, right? Not a big money spinner, you can see all the other things make lots of money, right? 30 billion, 20 billion, a couple of million, yeah, in connected ambulance. But it saves lives, so politically it's very good and we're all happy with that. Can you travel down any of the M roads here without having a dropped call? No. And we're going to trust 5G, high speed, low latency. Yeah? Do you think it's going to work? It's not going to work if the SLAs are different. Today the SLA is on 95% coverage across the UK, right? Or across Europe, or across America, or across Australia, or across India, China. They're the same, right? Where the manufacturing facilities are, is not where the people are, right? Do you see the differences? This is the opportunity. But the challenge we have is that the targets that governments are setting because of lack of understanding of how to realise the 5G industrial use cases is not there. So that's why we also want your help to amplify these types of messages. We need collaboration between the regulatory people, the industry people and the telecom people. But these 2 use cases, bulletproof. You want to know where the money is? Follow the money, right? Haven't talked about speed, have I? It's all about money, yeah? Next one. 5G produces less than 4G, okay? You want to save the planet? You want to improve the contribution? Today, the sum of all the mobile networks, the estimate is around 1.2, 1.5% of the total carbon emissions. That's just the mobile networks. So this is actually Europe. This is the demand curve in Europe over the next 5 years. So this means everybody that's consuming data, that's the projection as of last year. If you take all the spectrum, 700, 850, 900, 18, 21, 26, you take these blocks of spectrum, whether you're EE or Deutsche Telekom or Orange, it doesn't matter who you are, and you put 4G on, the best of 4G. You have a limit of capacity, right? So what happens when this demand curve hits the limit of capacity? Your only choice is densification. You need to build more sites, consume more power, right? You have no choice. What's the biggest problem for an operator? The biggest challenge for an operator, can I go back one? Yeah, the biggest challenge for an operator is operating costs. It's not the capital cost of the 5G. It's the site, the rental of the site, finding the site, backhauling the site, power at the site. So if you don't build it the right way and you don't use the right technology, you consume more. So, this is how we used to build it. I think you've seen all of those. You want to know what we're doing in China? This is 5G in China. This is in our Huawei University. Those of you who've been to Huawei University, you probably recognise that it sits in front of J. And these are examples just out the front of the apartment that I live in. So we're using street furniture. We're collaborating with the councils to build 5G sites. Is it surprising that these things cost less to build than this thing? Is it surprising that these things consume a lot less energy, between 10 and 25 times less? Yes, the equipment itself chews up 20% more energy, but it has 20 times more capacity. So the cost per bit per megahertz improves the entire operating position. So then the bottom line is this one. If we take every single country, and this is how this was modelled, and we look at how energy is derived in their country, how much of it is fossil-based, then you get a projection here of how much 4G will contribute to carbon dioxide. And if you take a couple of simple scenarios, you increase a little bit, but you can see the direction it's heading. And that's what 5G does. You want to put it in a different perspective? If we did 5G properly, you save around 100 megawatt power reactor per country. It's a sort of a very rough estimate. It's about 33.8 with 9 zeros kilowatt hours. That's a lot, yeah? So you can build more energy efficient power plants, or you can consume less using more efficient technology. That's why 5G produces less carbon than 4G. A little bit technical, a little bit complicated. I hope you've sort of picked up on it. So, digital systems. Let's take some examples. Yes, some robotic surgery that's being done here. One of the first ones was done between Hainan and Beijing Hospital. Let me give you a different example. In Luohu, in the small suburb of Shenzhen, we have operating over a couple of hundred kilometres, we have a remote ultrasound operating. So we have the technician sitting in one place and he's pressing on this device with tactile feedback. And a couple of hundred kilometres away, we have the lady with a machine here doing the ultrasound there. And it's doing it by itself. So she lies on there and it puts up there. You have a basic triage nurse sitting there doing this. And as you push over here, this thing here pushes and moves over there, right? Now, if the latency isn't low enough, as you push here, before I get the feedback, yeah, you got it, right? It's going to go a little deeper than you might have liked, yes? So this is a practical example of low latency in remote patient monitoring and distributing limited technical resources when you have a distributed population. And it doesn't matter whether it's in the UK or in rural China, they're the same. So these are practical examples of how. Now, why did we talk about trust? Level of trust in digital systems. Because now you're putting trust and you're distributing trust across a couple of different areas. You trust the triage nurse to be doing this, right? As opposed to an expert, a technician. You trust that the telecom operator has engineered the network end to end so the latency is low. Yeah? So suddenly trust doesn't sit with one person or with one company. I won't go through all of these examples, but I think you're familiar with things like virtual reality and augmented reality. I'd like to make a comment about VR and AR. I know a lot of my Huawei colleagues may be going to look unhappy at the way I say it, but today VR is indoor, right? How do you connect with your VR glasses today? By Wi-Fi. Yeah. Where's 80% of the traffic? Indoor. But hang on a second, I just showed you towers and outside. Just a moment, if 80% of the traffic is indoor, and the business of the future is virtual reality, which is indoor, and we're using Wi-Fi. Why not 5G? Because we haven't built 5G indoors. And a lot of the 4G is pretty poor, right? In here, limited 4G, in fact, zero down here in the basement. Only thing that connects here is Wi-Fi, because it's free. No grade of service, no security, but you sort of trust it. You see where I'm leading to? So VR, lots of opportunities, lots of applications, but you've got to do things differently. You've got to build it from indoor, outdoor. So you need to build indoor solutions, not outdoor solutions. That's why I don't believe that VR is going to be the takeoff that everybody thinks it's going to be. Just like I don't believe that connected car or autonomous cars for 5G are the... None of that. Where's the use cases? Follow the money. I didn't talk about autonomous cars. I didn't talk about transport. I didn't talk about AR or VR. I talked about some practical things. Where's the money? But there's no doubt that this is the direction of the future. I'd like to give you one here. I think you might have heard this before from me, but I call it facial recognition of the fish. Yeah, you'll remember that forever, and that's why I love it. So, we don't build the 5G base stations where the people are. Instead, we build them all along the Norwegian coast. Because I don't know if you know how salmon farming is done, but in all the fjords, they have these huge tanks. They look like this, it's a big mesh. And the water flows through. They've got pollution monitors, they've got quality of this monitors, they've got fish feeding monitors up here. The feed pops out of here, they've got cameras, they've got all sorts of things. They're connected by fibre to a boat, which is connected by fibre to the land. You can imagine the operating, the maintenance costs on this. But if we put in 5G, we bypass a lot of that. And if we put in 5G, we can identify pretty precisely the parasites on the fish. Remarkable, right? Because we're using a 4K camera. That improves the yield by about 4%. The operating maintenance costs by about $150 million. And we reduce the feed, because we can see precisely when the fish stop feeding, by about 20%. It's a great use case. It's an example of agricultural use case for 5G. What's the problem? We think that there are 4 areas. What I started with at the beginning, we need an education program. We need to talk about the facts. Facts about electromagnetic radiation, the facts about security, the facts about where the real money is in 5G, the facts about how to deploy 5G. Not to be scared of it. The second one, you can't do 5G without collaboration with all the industry players. It just doesn't work. The third one down here, we need I'll say, is it incentive? We need incentives. We need a different type of regulatory framework, I'll call it appropriate regulatory framework, to be able to encourage operators to invest this way and to encourage collaboration, because otherwise it won't happen. And the reason it doesn't happen is because of the bottom bit. You've got to change your DNA, you've got to change your mindset, you've got to look at things in a different way. And that's not what's being done generally across the industry. So with your help, this is what we think we need to do. I didn't talk about Huawei anywhere through the document. That's all. Thank you very much.